Okay, for unrestricted population growth or decline, compound interest, radioactive decay, drugs in your system, sort of, because there's some complicating factors. And there are complicating factors very possible with all the rest of these too. But the basic idea is the more is there, the greater the rate at which it changes. So if you've got a population, more organisms, you're going to get more, more new organisms. And if you got more money, then whatever percent you're getting is going to be a bigger chunk of money. Radioactive decay, the more atoms you have, the more atoms there are to decay, and the greater your rate of decay. Drugs in your system, the more drugs, the easier it is for your system to filter out, or the more your system will filter out. Okay, I don't want to get into the biology of that because I don't know it. Okay, so the idea is the more that's there, the greater the rate of change, and also for these models, we expect that the rate of change is proportional to, is in direct proportion to the amount you have. Okay, so the rate of change is in direct proportion to the amount you have. So if y is the amount you have, then dy dt is the rate at which it changes, assuming we're changing in time, and that'll be the case here. So you get this equation, rate of change proportional to how much you got. Very easy to solve. You get y equals ae to the kt. We've done this. And you almost certainly did this in first year calculus. Okay, so when do you have half of what you started with? Well, it's when ae to the kt is equal to half a. T for which ae to the kt is 1/2 a is going to be the, and I don't remember what I said the first sentence, but the t that corresponds to that is going to be the time it takes to go down to half. And the solution to that is very simple. T is natural log of 1/2 over k. And that's negative natural log of 2 over k. And I commented, if you don't know why the natural log of 1/2 is negative natural log of 2, except by memorizing a formula, you really ought to work it out so you really understand logarithms a little better. At this point you should. And actually in a pre-calculus course taught at the top level university, certainly you would have proven this a long time ago. Okay, and also this equation, which states that whatever time you start at, if delta t later you have half of what you started with, then delta t is the same thing. And that's what you would call half-life. If delta t is negative, then the absolute value of delta t is the doubling time. And you should work that out and think that through, totally understand that. Also, double check if k is greater than 0, you have increasing value of y. K is less than 0, you have a decreasing value of y. Exponentially increasing, exponentially decreasing. Exponentially increasing, exponentially decreasing. Wrong gesture before. Okay?